Well, I was expecting some kind of catastrophic failure with this, so sorry to disappoint. But I thought I might show you a couple of really cool things about right-angle worm gearboxes. So this is the input shaft. This is where the motor connects. You saw the big quill attached to it. This is the input shaft itself. So it's got a internal key. And that goes on directly onto the output of the motor. And the motor mounts in. And so that turns what is called a worm gear. And you can see that the grooves are diagonal. This one is a little bit interesting because it is what is called a multi-start. So you have a tooth here and a tooth here. Those are individual starts. So if you count, you've got 1, 2, 3, 4, 5, 6. 6 starts. So that means for every 1 revolution that this turns, it's going to turn the corresponding gear by 6 teeth. Which, perhaps that is why this one can be back-driven. Typically, worm gears cannot be back-driven. If the spur gear that intermeshes with these teeth try to turn, driving it backwards, what typically happens is this input shaft is driven horizontally. And since it can't go anywhere, it is captured inside of the gearbox, it cannot be back driven. However, because of the angle of this, plus you have a little bit of an angle on these teeth, I'm assuming that's why it can be back driven. So, here's your spur gear. And if you look at the spur gear, it actually has a little bit of a divot. And that is so that it matches up with this better. You get better contact across the face of the gear tooth by the gear tooth being curved. Because this is curved. They match. They're the same radius. And you can tell by the wear pattern on this, basically where it's shiny, that it's worn pretty well across the whole width of the tooth. Let's go ahead and do this backwards here. So that is how the worm gear rotates in here. And you can see that it's beginning to turn the spur gear. Well, if I can keep it from spinning out. So if we look at it from the other direction, hopefully you can see that there. That's how that matches up. So it is a right angle gearbox. You can typically identify right angle gearboxes because the input is at a higher level than the output. If they were bevel gears, then the input and the output would be at the same height in this direction. Since there's an offset, that's a really good indication that it's a worm gear. I'm not going to say you're for sure, but that's what I look for. I wanted to show you the housing here. So the center of this is where your output shaft is. Your spur gear fits in there. It's so big so you can get the spur gear in there. And this right here is your sight glass for the oil. So you fill the oil up until you can see oil halfway through this window. It's really grimy. Hard to see, but once oil gets in there, you can see it pretty good. You'll notice that it's not very high up on the housing. And moreover, the input shaft is well up out of the oil. Typically, that would not be a good thing. You'd be destroying your gearboxes. Worm gears are pretty neat, though, in that the... let's slide this in here like this. So your oil level is right about here. It's about to the bottom of your shaft. Come on. Which means your bearings are just dipped in it, and as the bearings rotate, it lifts the oil out and fully coats it. The same goes with the spur gear. The teeth get coated. And since gear oil is such a thick oil, it sticks really well. And it just inserts itself in between the teeth. And it's very effective. Uses just a smidgen of oil, not very much at all. These things are really robust. Great for speed reduction. You can get incredible speed reductions with worm gear. And like I said, typically, probably more so with higher ratio, this is a 5-to-1 gear ratio, which is pretty low. You start getting into 30-to-1, 60-to-1, 120-to-1. They cannot be back driven. Great for safety. Let's see. Let me also show you. Oh yeah, that's good. It's like syrup. God, I love gear oil. So let me talk to you about taper lock. So this is your hub, your taper lock hub, and this is going to be your sprocket. They come in all different kinds. This is for a gear belt, gear tooth belt. I've heard of them called both things. So there is a very slight taper on the inside of this, and this is one size. So instead of having to stock this pulley in 20 different bore sizes on the inside, this one fits a handful of different shaft sizes. And then what you do is you get hubs. So this is a 3/4 inch hub. You can see this hole and this hole are tapped, and those two are through holes. These two through holes line up with the tapped hole that is here and here. You'll notice that there's no hole opposite like this. And that is because you can see what I did is I took one of the screws out of here and I put it into here. And that pushes against the face of this, pushes against it and breaks this taper lock. And it's a very, very slight taper lock, but it is very strong and effective. Moreover, by having this crack down here like this, as the hub gets drawn into the taper of the sprocket, it closes down on that, which means that this now gets locked to the output shaft. You don't have to worry about it sliding one way or another. It is very effective, very strong, very industrial. This is a quality bore attachment. Very, very cool.